All right, welcome to The Explainer. Today we're going to crack the code on a number that, let's be honest, you've definitely seen but maybe never really understood. It's the silent partner to every single IP address, and it holds the key to how our networks are actually built. I mean, you've seen this everywhere, right? Every single device connected to a network, from your laptop to, I don't know, a smart toilet, has an IP address. And it always has this mysterious partner tagging along, the subnet mask. So what is its secret? What's it actually doing? Okay, so there's this simple hack you might have heard. Wherever you see a 255 in the subnet mask, that part of the IP address is just frozen. Can't touch it. But the real question, the one we're diving into today, is why? Why does 255 have that kind of power? So to solve this little mystery, to really understand what's happening under the hood, we gotta learn the secret language of computers. We need to talk about the binary key. All right, let's just get right into it. Computers, they don't think in numbers like 10 or 255 the way we do. Nope, they only speak in two digits, 1 and 0. It's a language called binary, and honestly, it's the key to everything here. You know, the way binary works is actually pretty simple. You can make any number, all the way up to 255, just by adding these 8 numbers together. It's kind of like having 8 light switches that you can either flip on or off, a 1 or a 0. And boom, here's the first big aha moment. When you add all those numbers up, when you flip every single one of those switches to on, what do you get? Exactly 255. So in computer language, 255 is just on, a solid block of 8 ones. And the opposite is even easier, right? The number 0? Well, that's just all the switches turned off. A block of 8 zeros. Super simple. Okay, so let's put it all together. When we translate our whole subnet mask, 255.255.255.0, into binary, you get this really clean, really clear pattern. 3 blocks of all ones, and then a block of all zeros. And this pattern, it's not just for show. It's actually a secret message. It's an instruction that's telling the computer and every router out there exactly what to do and how the network is all laid out. Yeah, it's almost like these ones and zeros are whispering the rules of the road for the network. They're defining the boundaries, the size, pretty much the whole nature of where your device lives online. And this right here, this is the core secret. The ons, they correspond to the network part of the address. Think of it as the zip code for the whole neighborhood. It's frozen. Then you have the zeros, and they correspond to the host part. That's the flexible bit, kind of like the street number for each individual house. So here's the bottom line. That long string of ones, it locks down the network address. It says, hey, everyone on this block has to have this same prefix. But the string of zeros, that's where the magic happens. It opens up a whole pool of available addresses for your computer, your phone, all your gadgets. All right, so now that we've decoded the secret message, let's actually use it. Because once you understand the power of those zeros, you kind of get a new superpower. You can look at a network and instantly know how big it is. I mean, this is the question everyone really wants to know, right? How many devices can I actually connect? Well, the number of zeros in that subnet mask tells you exactly that. It's not a mystery anymore. And guess what? There's a super simple formula for this that works every single time. First, you just count the zeros. Then, you take 2 to the power of that number. And last, you subtract 2. And we subtract 2 because a couple of those addresses are always reserved for special jobs. So, let's go back to our example. We had that one block of 8 zeros at the end, right? So 2 to the power of 8. That's 256. Subtract those 2 special addresses, and we are left with 254 usable IP addresses. Simple as that. Okay, but what happens when a business grows, or maybe you just get a bunch more smart devices for your home? What if you need more than 254 addresses? Can you change it? Oh, absolutely. The secret is actually really simple. If you need more addresses, you just need more zeros. And the way you get them is by borrowing a bit from the network part of the address, flipping a 1 over to a 0. So watch this. We're going to take the very last one from that network portion and just flip it. We're changing it to a 0. Now, that seems like a tiny little change, but trust me, its effect is huge. Okay, so remember where we started. 8 zeros gave us 254 usable addresses. That was our baseline. But now, just by flipping that one single bit, we have 9 zeros. So what's 2 to the power of 9? It's 512. Subtract 2, and you've got 510 addresses. We literally just doubled the size of our network by changing one little bit. How cool is that? And this whole magic trick, changing the subnet mask to make a network bigger or smaller to fit what you need, well, it has a name. It's called subnetting. And now you know the fundamental idea behind it. And really, that's the biggest takeaway here. A subnet mask isn't just some random number that your computer gets. It's this incredibly powerful and dynamic tool that lets you design and organize networks of any size. By learning its language, we've totally uncovered its secret. So, you've just cracked the first code. You can now look at a subnet mask and actually see the size and shape of the network behind it, all because you understand the language of ones and zeros. But believe me, this is just the first step in understanding the language of how our entire digital world is connected.